digital imaging, a pixel, or PEL, picture element is a physical point in a raster image, or the smallest addressable element in a display device, so it is the smallest controllable element of a picture represented on the screen. The address of a pixel corresponds to its physical coordinates. LCD pixels are manufactured in a two-dimensional grid, and are often represented using dots or squares, but CRT pixels correspond to their timing mechanisms and sleep rates. Each pixel is a sample of an original image. More samples typically provide more accurate representations of the original. The intensity of each pixel is variable. In color image systems, a color is typically represented by 3 or 4 component intensities such as red, green, and blue, or cyan, magenta, yellow, and black. In some contexts, such as descriptions of camera sensors, the term pixel is used to refer to a single scalar element of a multi-component representation, more precisely called a photosite in the camera sensor context, although the neologism sensor is sometimes used to describe the elements of a digital camera sensor, while in others the term may refer to the entire set of such component intensities for a spatial position. In color systems that use chroma subsampling, the multi-component concept of a pixel can become difficult to apply, since the intensity measures for the different color components correspond to different spatial areas in such a representation. The word pixel is based on a contraction of pix, pictures, and L for element. Similar formations with L for element include the words voxel and texel. The word pixel was first published in 1965 by Frederick C. Billingsley of JPL, to describe the picture elements of video images from space probes to the Moon and Mars. However, Billingsley did not coin the term himself. Instead, he got the word pixel from Keith E. McFarland, at the Link Division of General Precision in Palo Alto, who did not know where the word originated. McFarland said simply it was in use at the time, circa 1963. The word is a portmanteau of picture and element, via pix. The word pix appeared in Variety magazine headlines in 1932, as an abbreviation for the word pictures, in reference to movies. By 1938, pix was being used in reference to still pictures by photojournalists. The concept of a picture element dates to the earliest days of television, for example as Bildpunkt, the German word for pixel, literally, picture point in the 1888 German patent of Paul Nipkow. According to various etymologies, the earliest publication of the term picture element itself was in Wireless World magazine in 1927, though it had been used earlier in various U.S. patents filed as early as 1911. Some authors explain pixel as picture cell, as early as 1972. In graphics and in image and video processing, PEL is often used instead of pixel. For example, IBM used it in their technical reference for the original PC. A pixel is generally thought of as the smallest single component of a digital image. However, the definition is highly context-sensitive. For example, there can be printed pixels in a page, or pixels carried by electronic signals, or represented by digital values, or pixels on a display device, or pixels in a digital camera, photosensor elements. This list is not exhaustive, and depending on context, there are several terms that are synonymous in particular contexts, such as PEL, sample, byte, bit, dot, spot, etc. The term pixels can be used in the abstract, or as a unit of measure, in particular when using pixels as a measure of resolution, such as 2400 pixels per inch, 640 pixels per line, or spaced 10 pixels apart. The measures dots per inch (p) and pixels per inch (p) are sometimes used interchangeably, but have distinct meanings, especially for printer devices, where p is a measure of the printer's density of dot, e.g. ink droplet placement. For example, A high-quality photographic image may be printed with 600p on a 1200p inkjet printer. Even higher MP numbers, such as the 4800MP quoted by printer manufacturers since 2002, do not mean much in terms of achievable resolution. The more pixels used to represent an image, the closer the result can resemble the original. The number of pixels in an image is sometimes called a resolution, though resolution has a more specific definition. Pixel counts can be expressed as a single number, as in a 3-megapixel digital camera, which has a nominal 3 million pixels, or as a pair of numbers, as in a 640 by 480 display, which has 640 pixels from side to side and 480 from top to bottom, as in a VGA display, and therefore has a total number of 640 multiplication 480 equals 307,200 pixels or 0.3 megapixels. The pixels, or color samples, that form a digitized image, such as a JPEG file used on a web page, may or may not be in one-to-one correspondence with screen pixels, depending on how a computer displays an image. In computing, an image composed of pixels is known as a bitmapped image or a raster image. The word raster originates from television scanning patterns, and has been widely used to describe similar halftone printing and storage techniques. For convenience, pixels are normally arranged in a regular two-dimensional grid. By using this arrangement, many common operations can be implemented by uniformly applying the same operation to each pixel independently. Other arrangements of pixels are possible, with some sampling patterns even changing the shape or kernel of each pixel across the image. For this reason, care must be taken when acquiring an image on one device and displaying it on another, or when converting image data from one pixel format to another. For example, LCD screens typically use a staggered grid, where the red, green, and blue components are sampled at slightly different locations. Sub-pixel rendering is a technology which takes advantage of these differences to improve the rendering of text on LCD screens. The vast majority of color digital cameras use a Bayer filter, resulting in a regular grid of pixels where the color of each pixel depends on its position on the grid. A clip map uses a hierarchical sampling pattern, where the size of the support of each pixel depends on its location within the hierarchy. Warp grids are used when the underlying geometry is non-planar, such as images of the Earth from space. The use of non-uniform grids is an active research area, attempting to bypass the traditional Nyquist limit. Pixels on computer monitors are normally square, this is, having equal horizontal and vertical sampling pitch. Pixels in other systems are often rectangular, that is, having unequal horizontal and vertical sampling pitch. Oblong in shape, as are digital video formats with diverse aspect ratios, such as the anamorphic widescreen formats of the Rec. 601 digital video standard. Computers can use pixels to display an image, often an abstract image that represents a GUI. The resolution of this image is called the display resolution and is determined by the video card of the computer. LCD monitors also use pixels to display an image, and have a native resolution. Each pixel is made up of triads, with a number of these triads determining the native resolution. On some CRT monitors, the beam sweep rate may be fixed, resulting in a fixed native resolution. Most CRT monitors do not have a fixed beam sweep rate, meaning they do not have a native resolution at all. Instead, they have a set of resolutions that are equally well supported. To produce the sharpest images possible on an LCD, the user must ensure the display resolution of the computer matches the native resolution of the monitor. The pixel scale used in astronomy is the angular distance between two objects on the sky that fall 1 pixel apart on the detector, CCD or infrared chip. The scale S measured in radians is the ratio of the pixel spacing p and focal length f of the preceding optics, S equals pf. The focal length is the product of the focal ratio by the diameter of the associated lens or mirror. Because p is usually expressed in units of arcseconds per pixel, because 1 radian equals 183.14159 3600 equals 206,264 arcseconds, and because diameters are often given in millimeters and pixel sizes in micrometers, which yields another factor of 1000, the formula is often quoted as S equals 206 pf. The number of distinct colors that can be represented by a pixel depends on number of bits per pixel, BPP. A 1 BPP image uses 1 bit for each pixel, so each pixel can be either on or off. Each additional bit doubles the number of colors available, so a 2 BPP image can have 4 colors, and a 3 BPP image can have 8 colors. 1 BPP, 21 equals 2 colors. 2 BPP, 22 equals 4 colors. 3 BPP, 23 equals 8 colors. 8 BPP, 28 equals 256 colors. 16 BPP, 216 equals 65,536 colors. 24 BPP, 224 16.8 million colors. For color depths of 15 or more bits per pixel, the depth is normally the sum of the bits allocated to each of the red, green, and blue components. High color, usually meaning 16 BPP, normally has 5 bits for red and blue, and 6 bits for green, as the human eye is more sensitive to errors in green than in the other two primary colors. For applications involving transparency, the 16 bits may be divided into 5 bits each of red, green, and blue, with 1 bit left for transparency. A 24-bit depth allows 8 bits per component. On some systems, 32-bit depth is available. This means that each 24-bit pixel has an extra 8 bits to describe its opacity, for purposes of combining with another image. Many display and image acquisition systems are, for various reasons, not capable of displaying or sensing the different color channels at the same site. Therefore, the pixel grid is divided into single color regions that contribute to the displayed or sensed color when viewed at a distance. In some displays, such as LCD, LED, and plasma displays, these single color regions are separately addressable elements, which have come to be known as subpixels. For example, LCDs typically divide each pixel horizontally into 3 subpixels. When the square pixel is divided into 3 subpixels, each subpixel is necessarily rectangular. In the display industry terminology, subpixels are often referred to as pixels, as they are the basic addressable elements in a viewpoint of hardware, and they call pixel circuits rather than subpixel circuits. Most digital camera image sensors use single color sensor regions, for example using the Bayer filter pattern, and in the camera industry these are known as pixels just like in the display industry, not subpixels. For systems with subpixels, 2 different approaches can be taken. The subpixels can be ignored, with full-color pixels being treated as the smallest addressable imaging element, or the subpixels can be included in rendering calculations, which requires more analysis and processing time, but can produce apparently superior images in some cases. This latter approach, referred to as subpixel rendering, uses knowledge of pixel geometry to manipulate the 3 colored subpixels separately, producing a slight increase in the apparent resolution of color displays. While CRT displays use red-green-blue masked phosphor areas, dictated by a mesh grid called the shadow mask, it would require a difficult calibration step to be aligned with the displayed pixel raster, and so CRTs do not currently use subpixel rendering. The concept of subpixels is related to samples. A megapixel, MP or MPX, is 1 million pixels, and is a term used not only for the number of pixels in an image, but to express the number of image sensor elements of digital cameras or the number of display elements of digital displays. For example, a camera that makes a 2048 multiplication 1536 pixel image typically uses a few extra rows and columns of sensor elements and is commonly said to have 3.2 megapixels or 3.4 megapixels, depending on whether the number reported is the effective or the total pixel count 17, as opposed to the 2048 multiplication 1536 equals 3,145,728 finished image pixels. Digital cameras use photosensitive electronics, either a charge-coupled device (CCD) or complementary metal oxide semiconductor (CMOS) image sensors, consisting of a large number of single sensor elements, each of which records a measured intensity level. In most digital cameras, the sensor array is covered with a patterned color filter mosaic having red, green, and blue regions in the Bayer filter arrangement, so that each sensor element can record the intensity of a single primary color of light. The camera interpolates the color information of neighboring sensor elements, through a process called demosaicing, to create the final image. These sensor elements are often called pixels, even though they only record one channel, only red, or green, or blue of the final color image. Thus, 2 of the 3 color channels for each sensor must be interpolated into so-called n-megapixel camera that produces an n-megapixel image provides only 1/3 of the information that an image of the same size could get from a scanner. Thus, certain color contrasts may look fuzzier than others, depending on the allocation of the primary colors. Green has twice as many elements as red or blue in the Bayer arrangement.